So one of the things we looked at is if we could, and I'm just going to pretend this equation got factored and we're actually using numbers here, so I'm going to say x minus 1 and x minus 5. If you can factor an equation, then setting that equation equal to 0 means that you can find both the x-intercepts. So in this case, with the numbers I made up, you would get x-intercepts at 1 and at 5. I chose those numbers because they kind of match up, imagining this being at 1 and that being at 5. This is the picture that we're looking at is at the bottom of page 301. We call this the factored form of the equation of the line. And the factored form helps us because you could draw both of your x-intercepts. And once you have both of your x-intercepts, you can find the axis of symmetry. This should be one you should be able to just look at it and tell me, what is the axis of symmetry? X equals, now if it's symmetrical, it's got to be the same on both sides. And I've got 1 here and 5 here. This has to be right in the middle. Can you see that it would have to be x equals 3? That 3 is right in the middle between 1 and 5? And they give us a formula right here that says one way you could find it is you could just add 1 plus 5 and divide by 2. Because that's like finding the middle, like finding an average. What's the average between 1 and 5? Right? Your first test of the year in English, you get 1%. Second test, you improve. 5 times better, you get 5%. What's your class average? 3%. Oof. Got to work a little bit. And then once you have your axis of symmetry, and this might be something you want to highlight. This is what I have on the bottom of my page here. This is on page 302 for you. The constant term in the equation of the axis of symmetry is the x-coordinate of the vertex. So we now know that our vertex is 3 comma something. How do I find out what that something is? I could plug 3 into my equation. 2 times negative 2 would be negative 8. So I plugged 3 back into my factored form of my equation and found out what y was. And since I know that 3 has to be the x-coordinate of my vertex, I can find my vertex that quickly. So now we've gotten sort of 2 ways to graph something. We can either graph it if we have it in, like if this equation here was given to you like this, x minus 3 squared minus 8, that's probably the best for you so far for graphing. You would say, I know my vertex is at 3, negative 8, and I know I go over 1 up 2, over 1 up 6, and so on. But now, if we can factor it, it might prove even easier or a different way to be able to graph it. So how do you know which one to use? Well, you have to make a decision whether or not you think is factoring easier or is completing the square easier. So if I look at example 1 here, it says identify the intercepts. So if I have to find the x-intercepts anyways, I have to factor to find that out. So I'm going to start with this equation by factoring out the negative 2.5. That would leave me with x squared minus 3x plus 4. Does it factor nicely? It does. X minus 4. Oh, this would be a minus 1, sorry. That would be a negative 4 if I factored out, and this would be a plus 3. There we go. X plus 4, x minus 1. If I want to find my x-intercepts, that's setting 0 for y. It's already factored. It becomes a quadratic equation. And so x equals -4 and x equals 1 are our x-intercepts. If we were drawing a graph off to the side, often drawing a graph helps you see what's happening. We now know that we have an x-intercept there and an x-intercept there. If I add up those values and divide by 2, I get my axis of symmetry at -1.5. If you want to find your y-intercept, finding a y-intercept means you're going to plug in 0 for x, because it's going to cross your y-axis. It's probably easiest to go to your original equation and plug in 0 for x, because then you're going to get y equals -2.5 times 0 squared minus 7.5 times 0 plus 10. And from that, it might be really easy to see that your y-intercept is going to be 10. So we found our x-intercepts and our y-intercept. We've labeled our axes of symmetry. The last thing it's asking us to find are the coordinates of the vertex. Here too, using the factored form is probably the easiest way to find this. If I take my equation, I'm just going to drag it down here so we can see it again. If I take my equation and I plug in -1.5, can you see that you had -2.5? In here, -1.5 plus 4 will be 2.5. And here, -1.5 minus 1 will be -2.5 again. Type that into your calculator, and you get 15.625. Which means our vertex is at -1.5, comma 15.625. We could go to our graph and add that in there and finish drawing our parabola if we like. So the question asked us, going back to read it again, to find the intercepts. We've done that. We calculated the axis of symmetry. And as soon as you find the axis of symmetry, you know that the x-coordinate of your axis of your vertex has to be the same as your axis of symmetry. I plugged in that value for x, and we found out that y was 15.625. All right, questions for practice on this one? 3, 4, and 5.